Dear students, Assalamu alaikum. This is chapter 6. Okay. This is about the passive circuit elements. In frequency domain. Till now we have studied about the passive circuit elements. The passive circuit elements means the resistor, the inductor and the capacitor. We have studied about them in the time domain, and this chapter will be studying about them in the frequency domain. So prior to that, we will introduce the concept of what is a phasor. Okay. See, you have the Euler's identity, right? The Euler's identity in mathematics is given by identities like this. If you have e raised to plus j theta, that will be cos theta plus j sin theta, right? And you have e raised to minus j theta equal to cos theta minus j sin theta. These are two identities called Euler's identities. So you can write, use no cos theta is the real part of e raised to j theta, and sin theta is the imaginary part of e raised to j theta, right? So you can write that cos theta equal to real part of, right? It is the real part of e raised to j theta, right? Because e raised to j theta is a complex number. The real part is cos theta, and you can write sin theta is the imaginary part, right? It is the imaginary part of e raised to j theta. These things we have already studied in mathematics, right? Now we will extend this concept to the signals. For example, if you have a signal given as a voltage signal given as v of t, right? And this signal, you can write the signal as Vm cos omega t plus a phase angle phi, right? So you know from the previous section, you know cos omega t is the real part of e raised to j omega t, right? So you can write this as, using that particular identity, you can write this equal to Vm of real part of, right, e raised to j omega t plus phi, isn't it? Using Euler's identity, right? So you can even simplify. You can simplify it further. You can write it as Vm real part of e raised to j omega t multiplied by e raised to j phi, isn't it? So you can write Vt equal to real part of Vm e raised to j phi. Simply changing the order, that's all. E raised to j omega t, right? So you can write the relation like this, isn't it? So I will simply take out this particular quantity, right? So you can write this as that quantity is called a phasor. I will write it like this: V. Okay, V equal to Vm e raised to j5. Okay, this is a complex number, right? It contains amplitude as well as, right? It contains amplitude. Amplitude is there, and phase is there, right? Phase is phi, right? Amplitude is Vm, right? Complex number, right? So it's a complex number, right? Contains phase, right? Phi and amplitude. It does not specify anything about the time domain behavior of the signal. The time is given by that, the time aspect is given by this e raised to j omega t. So this particular expression, which is a complex number, it contains information regarding the phase as well as amplitude, but it does not specify anything regarding the time domain behavior of the signal, right? So that is called a phasor. Okay, this is called a phasor. We can call it a phasor. Understand? So for any time domain signal expressed in sinusoidal terms, you can find out an equivalent phase, this thing, right? So you can write always the phasor V, as you see, V is a phasor, right? It is in bold. It is given as Vm e raised to j5. But as you know that we have studied earlier, we can represent it as Vm angle phi. Okay. And in that case, the corresponding time domain signal, you can write it as Vt equal to real part of that phasor V. Okay, V e raised to j omega t. Understand? And you can write a V also like this. V is Vm e raised to j phi equal to Vm cos phi plus jVm sin phi, right? These are all simple expressions. So this phasor, what it does is it transforms a time domain signal into a complex number. Okay, that's what a phasor does. Okay, now we will see some examples. For example, if you have a signal V of t equal to Vm cos omega t plus phi, it can be transformed into a phasor V, which equal to Vm angle phi. Okay. Now suppose if you have a signal V of t, another signal V of t equal to Vm sin omega t plus phi, right? Understand? Then if it is omega t plus sin omega t plus phi, then it can be transformed into a phasor Vm angle 5 minus 90. Because the reason is, sin theta equal to cos theta minus 90. That's the reason. Okay. It's because of that. So if it is Vm sin omega t plus phi, you can write it as Vm phi minus 90, right? Similarly, you can write it a current signal, if it is Im cos omega t plus some theta or whatever it is, you can write it as Im theta, right? And if it is Im sin omega t plus theta, you can write it as a phasor Im, right, theta minus 90 degree. That's how you will write the various phasors. Now we will do a simple example. Okay. We'll do an example. We have a signal Vt equal to 170 cos, right, 377t minus 40 degree volt. What is the corresponding phasor? The corresponding phasor is given by V equal to 170 is the amplitude and minus 40 degrees the phase, right? Similarly, if you have a signal I of t equal to 10 sin 1000 t plus 20 degree, right, ampere, the corresponding phasor is given by, you can give the corresponding phasor as 10 amplitude 20 minus 90, right? So I can write it as 10 angle minus 70 degree ampere. See, in this phasor, the frequency information or the time information is not coming into picture. Understand? That's how you will do the phasor. Always remember one thing, that we are defining the phasor in terms of the cosine, not in the terms of sine. If you are getting a sine wave, you have to convert it as sin A equal to cos A minus 90, right? Like that, you have to make the conversion from sine to cosine. Okay, that you have to do. Now we'll do another example here. Okay, we have a signal, a phasor is given here. Okay. You are given a phasor as 18.6 angle minus 54 degree. Okay, what is the corresponding time domain signal? You can write it as 18.6 cosine, right? You don't know the frequency because phasor cannot give you any information regarding the frequency, right? You can write only like this, cos omega t into 44 degree volt, right? This is the time domain. This is the phasor. This is phasor. This is time domain signal. And one thing you note here, this omega value, it cannot be known from the phasor. Understand? And if there is an example 1, this is example 1. If you have an example 2, you are given minus 10 angle 30 degree volt. A phasor, voltage phasor is given like this. So you can write it simply as minus 10 cos omega t plus, right, 30 degree volt, right. We can write it like this. So if you want, you can convert the minus 10 into plus 10. Okay, you know we have a relation like minus cos theta, right, equal to cos 180 plus theta, isn't it? Is it okay? So if you use this relation into this thing, you can write this as that equal to 10 cos omega t plus 180 plus 30. That will be 10 cos omega t plus 210 degree, right? So this is a qanun, a law that you can use, which is something that you have studied in school, right? This particular law. So in that case, you can convert the negative amplitude to the positive amplitude. That's better. You always make the amplitude a positive value. Okay. Now the third example given is I equal to a phasor given as j, that is imaginary number, complex number, 5 minus j then 12 ampere. This is also a phasor. You can multiply j into j's, you know, j into j equal to minus 1, right? Minus j into j equal to 1, right? So if you use those identities here, this will come to be equal to 12 plus j5, right? Isn't it? So what is the amplitude of this thing? So the amplitude of this is square root of 12 square plus 5 square, and the angle is given as this thing we have studied earlier, right? Tan inverse y by x, that is 5 by 12, right? So you can write this as 13 angle 22.62 degree. You have to calculate this, right? So if you convert it into time domain, you can convert it as 13 cos omega t plus 22.62 degree ampere. So when you are given a complex number, you convert the complex number into the amplitude phase form, that is phasor form, using the identity, the law that you have already studied before, right? Now we have another example. Okay, let's study another example. That is given by, you have I equal to 20 angle 45 degree minus 50 angle minus 30 degree milliampere. That's a phasor that you are given like this, right? Okay. So what you will do about this particular thing? You have to convert it, right? You have to convert this thing to a single complex number, then again convert back. Okay. You can write this as, for example, 20 angle 45, right? 20 angle 45 minus 50 angle minus 30 degree milliampere, right? So what we can do is, we can do it as This is equal to 20, right? 20 cos omega t plus 45 degree minus 50 cos omega t minus 30 degree milliampere. That's how you have it, right? So that's enough actually. If you want to further simplify it, what you can do is you can expand the whole thing, right? Expand the whole thing and find out the answer. But I think this is sufficient. You can represent it as a sum of two sinusoids. That's enough. You can do, and otherwise also you can do like this. If you have something like a cos omega t plus b sin omega, b cos omega t something, you can do the simplification for that thing. Or else what you can do is, you can, for each value you have to find out the corresponding, what we can say, the complex number, and sum up all those things and convert them again back to phasor, and then convert to time domain. That's how you will do it. Okay. The next question is something like this: 20 plus j80 minus 30 angle 15 degree. Okay. In this case, you first convert this thing to a phasor form. That is, you have it as square root of 20 square plus 80 square angle, right? Tan inverse 80 by 20 you find out, minus 30 angle 15 degree, right? Then you can convert them into the time domain. Okay, that's how you will do the thing. Now we will study one more topic, right? We will study the resistor. You have for a resistor the Ohm's law, right? You know, if you have a resistor like this, with the current flowing through, this is I, and the voltage between this is V, right? You know, and this resistance value is R. According to the Ohm's law, V equal to I into R, right? Or you can write it as R into I, isn't it? Okay. So if you have IT equal to Im cos omega t plus t, right? Then you know the voltage Vt will be equal to R Im cos omega t plus theta, isn't it? Okay. So you can always write Vm V, right? The phasor for V is given as R into, isn't it, Im e raised to j theta, isn't it? So you can write it as Rim angle theta, isn't it? That's a phasor rule. So you can always write the phasor for the voltage equal to R times the phasor for the current, right? The phasors are proportional for the voltage and the current in the case of a resistance. Okay, so you can represent it like this. Okay, for example, you can represent it in a phasor diagram, right? This is a phasor diagram, and this is the real part, and this is the imaginary part, right? And you have, this is the current. Okay. This is the voltage. Both of them have the angle theta, right? Understand? Both are in phase. That is what it means. Both phase angle for both are same if you draw the phasor diagram. And if you draw it as a waveform, also you can see if this is this is the current, okay, this is the current, this is the voltage. Both are in phase. Understand? In phase. Both are in phase. Current and voltage in phase, right? Both are having same phase. This is 0. This is T, right? So this is the phasor diagram for a resistor. Okay. So that's how you will find out the phasor diagram for a resistor. Now we'll study what it is for an inductor. If you take the case of an inductor, you have an inductor like this, right? Inductor is this is V, and you have a current I flowing through the inductor, right? And the impedance of the inductor is given by J omega L. If L is the value of the inductance, okay. Now you see you have the relation for inductance is given by Vt equal to L di by dt, isn't it? For example, if I am putting L dit by dt, right? If I am putting it equal to Im cos omega t plus theta, okay. In phasor terms, you can represent it as Im angle theta, right? Then what is Vt? Vt will be L times, right? You have to differentiate this thing, particular thing. So you will get it as, if you differentiate cos, you know it is sine. Omega also will come here, right? So it will be L times omega L, right? So you will have it as omega L, right? Then Im, isn't it? Omega L Im, and the negative sign will be there because cos, when you differentiate, you will get sine, right? Omega L sine omega t plus theta, isn't it? Clear? Omega L Im sine omega t plus theta. Now you can further simplify it as minus omega L Im cos omega t plus theta, then you can write it as plus 90 degree, right? Okay. The law we have used here is like this, because you see, you know, you have minus sin A equal to cos of A plus 90 degree. So I have used that particular law here. So you'll get it like this, isn't it? So you can write this as V equal to, right? You can write V, the V is for V equal to omega L Im, okay, then e raised to j theta plus 90 degree, right? So write like that. You can further simplify it as, okay, it can be written as V equal to omega L Im e raised to then j theta, right? Then e raised to j 90 degree, right? Right. Then you know, you can simplify e raised to j 90 equal to cos 90 plus j sin 90, right? So it will be j, right? So sin 90 is 1, cos 90 is 0. So if you substitute it here, you can write it as j omega L Im e raised to j theta, right? You know the phasor for the current I is Im e raised to j theta. So that means the phasor for the voltage in the case of an inductor is given by j omega L into the phasor for the current. Okay. So there is this j term, as you can see here. This j term corresponds to a phase shift of 90 degree. So there is a phase shift, right, between V and I of 90 degree. That's very important for an inductance, for understanding the inductance, right? So V leads, right? V leads the current. Okay, V leads the current. In phasor terms, we will represent it like this. In the phasor diagram, we can represent it like this. Okay, if this is I, okay, with an angle phi theta, okay, then you have to draw a 90 degree thing here. This angle is 90 degree, and this will be V. So V is leading, right? You can say V leads I by 90 degree. So if you are drawing the waveform, you can draw the waveform like this. Okay. If this is the current, this is the current. Okay. Then the voltage. Okay. The voltage becomes maximum here. Okay. And goes like this. Okay, goes on like this. So this is the voltage scale. You can see the voltage becomes a maximum by leading the current by an angle of 90 degree. V leads I by 90 degree. That is the relation for a inductance. Similarly, for a capacitance also you can think of a relation. Okay. You have a capacitance here. Okay. Suppose if you have a capacitance, right, and there's a voltage across the capacitance, there's a current through the capacitance, right? The value of the capacitance is C, right? And you know the relation between the voltage and current of a capacitance is given by IT equal to C d Vt by dt, right? So suppose if I am specifying a voltage of Vt equal to Vm cos omega t plus theta, right? Then you know It will be equal to C dV by dt, right? That will be, you can write it as cos theta. When you differentiate, you will get sin theta. So you can minus sin theta cos theta. When you differentiate, you will get minus sin theta. Similarly, you will have it as omega c times Vm sin omega t plus theta, right? That is how you will get it. So you can again write it using the same relation that we have used before. You can write it as omega c Vm cos omega t plus theta plus 90 degree, right? So you can write the phasor in this case as, right, this is omega c Vm, right, e raised to j theta plus 90, right? Clear? And in this case you can find out that I equal to the phasor I equal to j times omega times c times the phasor V, right? For the inductance, you might have noted that for the inductance it is given like this, right? V equal to for j omega L I. This is for the inductance, right? So for the capacitor, you can see the current leads the voltage, right? For the inductance, the voltage leads the current. For the capacitance, current leads the voltage, right? So you can draw the phasor diagram like this for the capacitance as, okay. Suppose if this is the voltage, see, this is the voltage or theta, whatever it is. This is the voltage. Now we can have a current. This is the current. This is the voltage. This angle is 90 degree. Okay, current leads the voltage, and you can draw the waveform like this, right? This is the current. This is the current waveform. This is the current waveform. Okay. So the voltage is lagging the current, right? So the current voltage is coming like this. So the current becomes maximum first, and the voltage is lagging the current, or the current is leading the voltage. That's what happens in the case of a capacitor. Understand? Now we will do an example 3. You do an example 3. You have a voltage Vt equal to 12 cos 60t plus 45 degree, right? This is applied to an inductor. This is applied to an inductor, right? Find the current through the, find the steady state current through the inductor. Find the okay. You write the exam sum, right? What is, you have the, for the inductor you have the law, right? V equal to j omega L I, right? Where I is the phasor of the, and you know I is what? I equal to V by phasor V divided by j omega L, right? And for the phasor V you have it is 12 angle, right? 45 degree, isn't it? Divided by j omega is 60, isn't it? You know, this is omega. Omega is 60. So you can write it as omega into 60. Inductance value is, you have of value, you have 0.1 Henry. Okay. So you can write it as 0.1, isn't it? So you can further simplify it. You can write it as 12 angle 45. So when something is multiplied by j, that is like it is having a phase angle of 90 degree, right? 16 to 0.1 is 6. 6 angle 90, right? Clear? Because j multiplying with j is equivalent to a phase angle of 90 degree. So this will be 2. 12 by 6 is 2. 45 minus 90 is minus 45 degree, right? Isn't it? 45 minus 90, right? So the answer will come as 2 angle minus 45 degrees in phasor term. So you can convert it into time domain as 2 cos. You know the frequency does not change for linear elements. 60/80 minus 45 degree ambient. This is how you can find out the answer for questions in the using the phasor technique, right? Understand? Now, impedance. We will study about what is an impedance. In general, in circuit analysis, we say the impedance Z. Impedance Z is given by the phasor V divided by the phasor I. Ohm's law itself. Or you can write the phasor I equal to Z times, okay, the voltage V, phasor of the voltage V equal to Z times the phasor of the current I, right? Now, if you go for the resistance, you know, for the resistance, you have V, the phasor V equal to R times phasor I, right? So in that case, Z equal to R equal to phasor V divided by phasor I. Understand? This is for the resistance. Now if you go for the inductance, you know you have the phasor V. For the case of an inductance, your phasor V is given by j omega L I, right? Phasor I, isn't it? So you can have Z equal to the impedance Z is given by V by I equal to j omega L. So this is for the case of an inductance. Similarly, if you take a capacitance, you know the relation between voltage and current, the phasor relation is given like this. For capacitance, you know V equal to 1 by j omega c into I, right? So you know Z equal to V by I, right? The phasor V divided by phasor I, and you can write it as 1 by j omega c. This is the impedance for a capacitance. That's how you will find out the impedance for the capacitance, inductance, and this thing. Right. So we'll do one more simple problem and conclude. You have inductance. Example 4. You have a 20 millihenry inductance. Okay. Current in the inductance is is 10 cosine 1000, it's a big frequency, 300t plus 30 degree milliampere. Okay. So what is the inductive reactance? Inductive reactance is omega L. Right. It is given by inductive reactance is omega L. Okay. That is omega is, this value is omega 10000 into inductance is 20 milliampere, that is 20 into 10 raised to minus 3. So it will come to be 2200 ohms, right? What is the impedance? Impedance is V by I, right? Okay. Impedance is given by, okay, j omega L. You will see the difference between reactance and inductance. So it will be j 200, right? So you know when 200 is multiplied with j, it is like shifting by 90 degrees, so it will be 200 angle 90 degrees. That's the impedance. What is the phasor voltage? The next question is, what is the phasor voltage? The third question is, you know the phasor voltage is given by V equal to Z into I, right? So that is 200 angle 90 multiplied by I. What is the phasor for I? Phasor for I is, you know, it is 10 milliampere angle, right? 10 milliampere, 10 into 10 raised to minus 3 angle and 30 degree, isn't it? So when you are multiplying two phasors, you have to simply add up the angles, right? Multiply 200 into 10 is 2000 into 10 raised to minus 3 is 2, right? So it will be 2 angle 120 degree. That's the phasor for the voltage, right? And actual voltage, time domain voltage, okay, steady state voltage Vt is given by 2 cos, right? Frequency remains the same, 1000 t plus 120 degree volt. That's how you'll find out the thing for a voltage case. Similarly, we will do a problem for the capacitor case also. And after that, we will conclude. Example 6, it seems. You have a 5 microfarad capacitor. You have a 5 microfarad capacitor. And voltage is given as Vt Vt is given as 30 cos, the voltage in the capacitor is given as voltage in the capacitor applied across the capacitor is given as Vt equal to 30 cos, right, 4000 T plus 25 degree volt, right. So what is the reactance? Reactance will be Xc equal to minus 1 by omega c, right. For inductance, you know, reactance is given by XL equal to J, no, XL equal to given by omega L for inductance, right. Inductance it is given like this. The capacitor is X equal to minus omega by C. So that will be minus 1 by, what is the frequency? Omega is 4000, right? Into, what is the value of the C? 5 into 10 raised to minus 6, 5 microfarad, right? So I will get it as minus 50 ohms. So it's having a minus sign, okay. Now, for capacitance, reactance, you always put a minus sign. Next question is to find out the inductance, the impedance of the capacitance. Impedance is actually written as Z, right? Z is, you can write it as J omega C, right? So it is minus J 50, okay, minus J 50 ohms. Minus J is equal to angle of minus 90 degrees, right? Minus J is an angle of minus J. Okay, J is 90 degree, minus J is minus 90 degree. So you can write it as 50 angle minus 90 degree. Okay. Now, what is the current? Current phasor for the current. Phasor current I equal to phasor voltage divided by Z, isn't it? What is the phasor voltage? That is 30 angle 25, isn't it? Divided by Z, that is 50 angle minus 90, right? So it will be 30 by 50, that is 0.6. 25 minus 90, that is 115 degree, right? So what is the time domain value of the current? What is the time domain value of the current? You can write the time domain value of the current IT equal to, convert that phasor into time domain, 0.6 cos 400t plus 115 degree ampere, right? That is how you will do the conversion of the voltage and current. So with this we will stop this particular lecture.